So in this video, we are going to complete the chapter How Forces Affect Motion, which is chapter 6 of our new NCERT Science Physics. So first, what is force? So normally, force is something which can make an object move from rest, change its speed, the direction of motion of a moving object, and can even change the shape of an object. But when you have to write proper definition of force, force is either the push or pull upon an object resulting from the object's interaction with the other body, and its SI unit is capital N, which is Newton, and it has both magnitude and the direction, and so it is a vector quantity, and the magnitude will signify its strength of force. And the primary effects of force, as we have read here, that it will change the speed, direction, state of motion, and the size and shape of the object. And how do you measure the magnitude of force? It is done with the help of spring balance. And force can be of two kinds, which is balanced force and unbalanced force. Balanced force is when multiple forces act on a body but cancel out each other. So the net force will be zero. Unbalanced is when the net force is not zero, and these forces act on the body and cause it to accelerate. Here net force is zero, here it will accelerate. So it maintains its state of rest or the uniform motion. So when both the sides will apply the same amount of force, then it is called balanced force because the net force is zero, while in unbalanced force, one of the sides will have a greater force, due to which, when you see in this example, that you have here 50 newtons and 40 newtons. So the difference is 10 newton. So the object will move from left to right. So this is the movement because there is a acceleration which is found due to the unbalanced force. And we have, suppose if we have an object, then there will be four forces which will be particularly acting on it. That is the applied force which the person will apply, and the gravitational force which will pull downwards, and there is a normal force which will cancel the gravitational force, and there is a force of friction which will prevent the object from moving. So these are all the forces particularly which are actually applied on a normal object which you see. And multiple forces may act on an object, but its motion depends only on the net force. Because if all of these cancel out each other, then there will be no movement in it. So when your applied force is greater than the force of friction, then only there will be a movement in the object. Sir Isaac Newton has proposed 3 laws of motion, which we are going to study in this chapter. That is the Newton's first law of motion, which is law of inertia. So what will it state? That is, an object remains at rest or continues to move with a uniform velocity in a straight line until and unless acted upon by some external unbalanced force. So for this, a stationary object will remain in stationary unless someone will push or pull it. Or a moving object will continue moving at the same speed in the same direction unless a force is acted upon it. So when an object is at rest, so a book lying on a table will remain at rest because there is no unbalanced external force on it. So this is one of the examples. Okay, so what is inertia? It is the property of an object by which it resists any change in its state of rest or in motion. So if an object is moving, it wants to move. If an object is in rest, it wants to remain in rest, and that is what we call it as inertia. So the greater the mass of the object, greater will be the inertia. And there are 3 kinds, which is inertia of rest, inertia of motion, and inertia of the direction. Inertia of rest is that a body at rest wants to remain at rest. Inertia of motion, and when if a body is in motion, it wants to remain in motion. And inertia of the direction is that it wants to continue in the same direction. Okay, so this is the Newton's first law of motion. Next, Newton's second law of motion is that the rate of change of momentum of an object is directly proportional to the applied force, and it takes place in the direction of that force. So what does second law of motion explain? It explains how much an object accelerates when a force is acted on it. So first, they have mentioned the change of momentum. So what is momentum? It is the quantity of motion which is possessed by a body. So when you take P to be as momentum, M to be as mass, and V to be as velocity, we have the momentum is equal to mass into velocity, and its SI unit is kg meters per second. So first, speaking of, suppose we have the mass m, initial velocity which is u, and the final velocity is v, and we have the time taken as follows. So the initial momentum, when you have the initial velocity which is p1 is equal to m into u, and the final momentum p2 is m into v. So the change in momentum will be final momentum minus initial momentum. When you take m common, we have m which is v minus u. So what is the rate of change of momentum? That is, you have to take, okay, so you have to remember that v minus u by t, that is velocity by the time taken, is what is known as acceleration. So when we put this in this equation, you will find that the change of momentum is equal to m into a. So as you already know that according to Newton, force is directly proportional to mass into acceleration. So therefore, when you replace this, you will have that force is equal to ma. So what is 1 Newton? Force SI unit is 1 Newton. So 1 Newton is 1 kg into 1 meter per second square, because it is of the acceleration part. Okay. So this is what is explained in the second law of motion. So examples of this is, a cricket ball is easier to throw than a football because it has less mass, which is one of the examples of second law of motion. Okay, so what is the importance of second law? Its importance is that it calculates force, it explains acceleration, and it is used in vehicle designs and used in rockets, aircraft, and machines. So now moving to the third law of motion, that is, to every action, there is an equal and an opposite reaction. So, whenever one object exerts a force on the other object, the second object exerts an equal force in the opposite direction. It is important to remember that action and reaction act on different objects, and they are equal in magnitude but they are opposite in the direction, and they occur simultaneously, which is very, very important. That is, action and reaction will occur simultaneously, not one after the other. So first, now speaking of all these things together, that is the first law of motion, second law of motion, the third law of motion. So the first law of motion explains inertia, and it's of the balanced forces, and the object remains at rest or in uniform motion until and unless you apply an external force on it. Second law explains how the force changes motion, and it focuses on the unbalanced forces, and here F is equal to m into a. Third law is where it explains the force pairs, action and reaction pairs, and the action and reaction are equal but in opposite direction. Okay, so when you speak of the examples for the third law, you'll see that the foot pushes the ground backward and the ground pushes the foot forward. So this is known as the action reaction. So you are placing a pressure on the ground, and ground also pushes the foot forward. So that is when we move forward. Okay, so what are the importance of third law? It explains walking, explains swimming, explains rocket propulsion, explains the recoil of guns, and explains the flight of jet aircraft. Okay, so now speaking of the force acting on system of objects. So first, what is system of object? So a system of objects measures two or more objects which are considered together as a single unit. So when we have these two blocks, so these two blocks are considered as a single mass. So when you have two blocks, we take it to be as mass m1 plus mass m2, which is 3 kgs plus 2 kgs, which is 5 kgs in total. And when you apply an external force of 20 Newton, so what is the mass which you take? 5. And the force is 20. So what is the acceleration? Which is 4 meter per second square, because you are taking the force acting on system of objects, and all these objects are taken to be considered as single one. So we have both the external forces and the internal forces. External force is that which act from the outside the system, Here we have the 20 newtons, which is an external force, and they cause the whole system to accelerate. Well, internal force, that is, they act between the object within the system. So for suppose if these two objects are actually bind together by a string, so there is tension force in between them, which is known as the internal force. This is not external, that is internal force. So this is all which we have got in this chapter. A quick revision, that is how forces affect motion.